Hey everybody, it's Mrs. Mancuso, and today we are doing calorimetry, doing a little practice here. So calorimetry, every time you see that word, I want you to think heat, and heat is equal to Q. So your Q formulas are on table T. We'll be needing those formulas today. So make sure you have your reference table and a calculator out and ready for this pre-quiz. All right, use the information to answer questions 1 through 3. You have a 50-gram sample of gallium at 350 K. What is the temperature of your sample in degrees Celsius? Well, I know that Celsius plus 273 is going to give me K. So if I already have K, I'm going to have to do K minus 273 to give me C. So I go 350, punching it in the calculator, minus 273 gives me 77 degrees Celsius. All right, what phase of matter is it in? So I'm going to look on table S on the reference tables. So turn to table S right now and find gallium. It's element 31. I go over to the right, going across gallium, and it tells me the melting point of gallium is 303. So if it's 350 K and it melts at 303 K, it has already melted. This is above the melting point, which means it is not a solid, it has changed to a liquid. So now I need to look at the boiling point and see if it's changed from a liquid to a gas. The boiling point is 2,477, so it is nowhere near boiling yet. So this sample is still a liquid. All right, next question. What's the number of joules of heat needed to change the temperature? So if I'm changing the temperature, I want Q equals MC delta T. So I'm going to solve for Q. My sample is 50.0 grams. C is the specific heat. If I had water, it would be 4.18, but I don't have water, so they have to tell me the specific heat. So they tell me it's 0.37. And I'm raising the temperature to 370, and it was 350, so that's a change of 20 degrees. Doesn't matter if you have it in Celsius or Kelvin, as long as you stay consistent, the change in temperature will be equal. So I'm punching in 50 times 0.37 times 20, and I get 370 joules. That's how much heat would be required for that change. Next question, how much heat must be added to completely boil 105 grams of water? So boiling is Q equals mHV. If I'm boiling, it's vaporization. The mass is 105 and HV for water is 2260. I'm looking right on the front page of my reference tables for that. So 2260 times 105 is equal to 237,300 joules. So it takes a lot of heat to change that into a gas because you got to break all those attractions between the molecules. All right, you have 240 grams of water at 10 degrees. How much heat is required to raise the temperature to 60? So if I'm raising the temperature, I want Q equals MC delta T, and I want you to be in the same practice that I'm in of as soon as you read a question, you're underlining what it is that's changing, and then you're writing down what formula of the 3 you need to use based on that information. So since it's changing temperature, I know that I needed the Q equals MC delta T formula. All right, my mass is 240. The specific heat of water is 4.18. And then I'm changing from 10 to 60. So the difference between 10 and 60 is 50 degrees. So I'm punching 240 times 4.18 times 50 into my calculator, and I get 50,160 joules. That's how much heat would be required to change the temperature that much. All right, it requires 7,500 joules to change the temperature of a sample from 40 to 60. How many grams are in the sample? And this sample has to be water that we're talking about here. So Q is equal to MC delta T. So the Q is 7,500. The mass is what I'm going to solve for. Specific heat of water is 4.18, and I'm changing from 40 to 60, so that's a change of 20. So the first thing I'm going to do is go 20 times 4.18 equals, whoops, 20 times 4.18 equals 83.6. I'm going to divide both sides by 83.6. That will cancel it off of this side, and my mass will be equal to 7,500 divided by 83.6. I get 89.7, and my unit is grams for mass. Next one, what is the heat of fusion? So if I have to find heat of fusion, my formula is Q equals MHF. So the mass is 35 grams, and it required 35,200 joules. All right, divide both sides by 35. This will cancel out. HF is going to be equal to, I'm punching in the calculator, 35,200 divided by 35 equals 1005.7. And so when I'm finding heat of fusion for a unit, this on top was joules and this on the bottom was grams. So this is joules per gram. All right, next question. 12,990 joules were added to a 40-gram sample of water at 10 degrees. What's the final temperature of the water? So if I have to find the final temperature, first I'm going to have to find the change in temperature. So here's my formula. So 12,990 is equal to 40 times 4.18 times delta T. I'm multiplying 40 times 4.18, and I get 167.2. So I'm dividing both sides by 167.2. That cancels that out. My delta T is now going to be 12,990 divided by 167.2 equals 77.7. Okay, that's the change in temperature, but that's not the final temperature of the water. I started at 10 degrees, so I got to go plus 10. So I started at 10, it went up by 77.7, so the final temperature is going to be 87.7 degrees Celsius. What is the heat of vaporization? So Q equals MHV is my formula every time I have vaporization of an unknown sample of 25 grams that required 300,000 to boil. All right, so 300,000 joules is over here. My mass is 25 grams, and I'm going to find HV. So divide both sides by 25. This cancels out. 300,000. Oops, do I have enough zeros? Yes. Divided by 25 equals 12,000. So HV is going to be 12,000. And then again, this unit was joules and this was grams. So my units is joules per gram. All right, next problem. What's the number of joules of heat needed to melt? Okay, if I'm melting, Q equals MHF because fusion is melting, freezing or melting is fusion. And I have 75 grams. My heat of fusion for water is 334. So I'm multiplying 75 times 334, and I get 25,050 joules. Okay, that looks like the end of our calculation problems. So the end of our pre-quiz is some graphing problems. So what is the boiling point of this substance? All right, so before I start, I like to label these. So I know down here where it's cool, it's a solid, and here it's a liquid, and here it's a gas. In this combination, this is where it is melting. So if it's melting, I've got a combination of solid and liquid still. By the time it gets to this point, it will be all changed into a liquid. And then from here to here, it's both a liquid and a gas because it is boiling or vaporizing. So the boiling point is this temperature right across from the second plateau. So 115 degrees Celsius. During what line segments is kinetic energy increasing? So kinetic energy, every time I see that, I remind myself, kinetic energy is temperature. So it is increasing from A to B, from C to D, and E to F. So the kinetic energy goes up at that point. Kinetic energy stays the same on B, C, and D, E. All right, during what line segments are potential energy increasing? So when the temperature stays the same, but heat is still being added, the potential goes up. So that's BC and DE. These two sections, the potential is increasing because I'm adding heat, but I'm not changing the temperature. I'm breaking those intermolecular forces of attraction. During which line segment does fusion occur? So I know fusion is my changing from solid to a liquid. So that's right there during BC. This is why in this section, I would use Q equals MHF because that's the heat of fusion. All right, so that is the end for our pre-quiz today. Make sure you go through, do as many practice problems as you need before you do the quiz on your own. Have a great day. Bye.